can see, hear me properly. So, so the Gihana actually give very well like good understanding about React, basically the front end development. So in I'm going to more focus on the backend application. So basically, we are going to create a REST APIs, and when we do the coding, actually, I will explain what is REST APIs and how you can create one for your ITP project. So uh, in let me share my screen. So if, just let me know if you can see my screen when it's visible.
Can see the screen.
Yeah. Okay. So, so first we are going to talk about like basically similar to the Rihanna edit. Actually, I'm more focusing on the coding instead of like giving you a like what is Node.js and basically like presentation slide. So I will directly go into the coding actually. Then while we are coding actually, I will explain some of the things and you can ask any questions that you want. Uh, yeah. So. Yeah, first we will talk about the project structure because we are going to create a project structure for your like Node.js application. So there are many ways like creating a project structure for Node.js actually. So we will create one, and then we are going to talk about the data layer with the ORM. So I will explain what is ORM, and so apart from the CRUD application, because CRUDs are basically like business functions that actually create, update, read, delete entities from the data layer actually. So we will talk about the CRUD, but uh, I will be more focusing on the like these areas like how you can properly log in the backend because logging is very important thing when it comes to backend development. So we will talk about logging and yeah. So if I have time, so I will explain like the data validation, basically the request validation as well. Uh, validation. So so yeah, let's more focusing on the logging, CRUD, and the data layer. How you can create a database, and how you can connect with use connect and manage it using ORM. Okay, so let's first focus on the project structure, the architecture of the project actually. Uh, so when we are doing a project, so especially in backend, having a good structure is very very important because otherwise, if the project when the project actually grows, if you does not have a proper like structuring and structuring the your project actually it is uh, your productivity of the coding actually may go down actually. So that's why having a good structure is very very important. So in this session, first we are going to like create a project structure. So I have already created one, but I will explain everything and also I will give this entire directory structure for you now. So if you can like code along with me. So I will share it in the chat. If you want, you can grab it from the GitHub. So let's focus on the folder structure. So the reason that I have created this one, creating a folder structure actually takes some time. So due to the time limitation, I have already created one, but I will explain and what are the dependencies that you want to create this folder structure. So uh, so and also this is not the like best the world best folder structure for your project, but you can like build on top of like UI implementation as well. So let me open the, so we have a, this is our directory structure. So we have a dist, basically our distribution, basically our build compiled code. And obviously we have node modules because we are using dealing with NPM and node. And like I will talk about Prisma in seconds. So then we have our source directory. I will talk about that in a minute. So, but I will explain these files because this is the main folder that we are going to working on. So I'm using Babel to basically transpile our ES6 syntaxes. And we have, I will explain these things like why we use Babel and what is the use case of it. And then we have .env. We will keep like basically use this env to like store all of our environment variables for our application. And so that's pretty much it for the .env. So, and then we have a SLIIT. So I will explain why SLIIT is used. So, and we have git ignore, obviously, because since we are using git as a version control, we need to ignore some unnecessary folders and files from pushing into the GitHub actually. So then we have pretty I will explain that as well. So basically, it's a like prettier, like formatting your code. Actually, we basically use prettier for that. And the combined logs and error logs, I will explain that. So in the logging section, and we have the package JSON log and the package JSON. So that's basically the structure. So the main structure. So I will now explain the more important part of this project structure, which is the source directory, where we are going to code our business logics. So in here, so we have a source directory. Under that, we have a couple of subdirectories. So we will go them in few minutes. So first I will start from the app.js, basically the root of your um, root file of your project. So in the app.js is the one actually start our Node.js application, and we can basically register new routes and error handling, all the middlewares we are going to register in here. So this is just basic boilerplate code that I have written so that you can, when we start coding, you can start coding with me. So to make it more interactive. So, and then we have utils. Basically, we are using utils for utils directly to like implement our utility components like logging and any other like uh, codes that are related as utility functions. And then we have middlewares. So basically, middlewares is for error handling, request validation. So I will explain the middlewares when we are implementing one. And then we have errors. So I'm going to talk about the error handling as well, so which is very, very important when it comes to backend development. So, and then we have configs. So basically this folder is to like include any configuration file that you want. It can be a database configuration, or if you're using cloud technology such as AWS, GCP, or the DigitalOcean, you can have your configurations in a separate folder or config folder. And then we have the API. So this is where our actual business logic and the routing, the controllers, all that we are going to implement. So just let me know if I'm going fast. Just let me know if I can slow down the explanation. So in the API directory, so there are many ways actually you can create a directory for your application. So basically you can do, use a directory structure something like this. So we have a currently API directory. Under that, we have our user, basically our feature. So, and then under that, we can have a controller file, and then we have a router file. Basically, this is the controller file is basically the API controller. This is the request response controller layer, and the router is the one that we are going actually give a path to our API. So in here, and then we have the service, basically the business logic. In this one, we only include business logic only, right? We are not going to handle any request response, any validation related to request response. This is purely business logic only. So then first we need to talk about like before we dive into coding. So what is an API? So API is basically stand for Application Programming Interface. So which you can use for like expose any backend implementation to front end or any other application. So you can expose your business logic as a REST endpoint. So so basically this is that is for API. So and then this is the folder structure that I'm going to use. And apart from that, you can use other folder structure as well. So you can use API folder, and then you can use like controllers. So basically, it's a directory and service and routes. You can use this approach as well. Uh, you can fit either way is good actually. So I'm using this approach so that I can isolate all the like route handling, control functions, and service functions within the folder that related to a particular feature in our application. So for example, so let's say in every most of the application we have a user that are going to use the application. So that's why we are having a user directory. And then let's say if you want to add the like any other scenario like uh, e-commerce application where you have like products, you can have another folder called products in here, products, and then inside this you can have products.controller.js and router.js, service.js, which have more like organized way of structuring your project. So project structure is very very important. So this way, when your project grows, so let's say you want to add any like new feature called like let's say uh, like delivery. So you can simply create a delivery folder or order maybe, and then include all the business logic and route handling there. So you can if something went wrong, where to exactly look. Let's say if some user related API is failing, so you can basically go inside this user because that is the place that actually uh, occurs like throwing that error. You can directly go to that folder and start investigating what went wrong. So, so that's the folder structure that we are going to use actually. And then, yeah, so that's pretty much it for the like folder structure that you can use. So you can grab this from the GitHub and start using. So yeah, so let's get started. So the first one that we are going to talk about is data layer with ORMs. So what is a ORM actually? So ORM is like it stands for object relational mapper. So basically it is used to like map our like basically the uh, objects. Basically it can be written in JavaScript or Java, any other language that can actually map into a relational or non-relational database in our application. So for example, let's say if we are using PostgreSQL or MySQL. So we have to write queries something like this. So I'm using my database. So yeah, something like this. Let me. So we are using some like SQL queries, something like this. So instead of implementing these queries in our code, we can have a like object that can actually uh, do this for us, like basically more readable functions. So I will explain like when we do the coding, actually we can get a much more clear idea about how we can use ORM and what is used for. So basically it used to simplify our process and process of querying the data from any other data source. So it can be Postgres, MySQL, and MongoDB. So any other database you can use. So there are a couple of like well-known ORMs such as let me list down some of it. So basically, we have type ORM. So mainly using TypeScript related backend. So if you are like implementing your backend using TypeScript, TypeORM is a good choice. And then we have Prisma. So is another ORM, so which we are going to use in this project, and many more. So we have a lot of like similar to the production, similar to programming languages. We have a lot of ORMs. So depending on your implementation of scenario, you can choose uh, more whatever the like ORM you want. So for this case, we are going to Prisma. So I'm going to start like go to their official documentation. So basically, this is how I like do coding. So so because we are not like storing all the syntaxes on like on our head. So I'm basically, if I try to start implementing API, probably I go to the documentation. So even these days, I'm lazy to go to the documentation because ChatGPT is there, so I can ask ChatGPT to create any like APIs or data layers. But for now, I'm more focusing on the documentation as well. So I'm going to call Prisma. So Prisma. So this is the official documentation of Prisma. So can start. So Prisma is basically a ORM, object relational mapper, that you can use Prisma to connect to your Postgres database if you are using SQL related database, and MySQL, SQL Server, and CockroachDB, and also the MongoDB. So I know as I like get it from the organization team, most of you actually use MongoDB uh, as your database, which is a document database. So you can use this. This is this ORM Prisma for MongoDB as well. So it is very good like production level ORM that you can use. So let me start. So since we are using MongoDB, so I will use Prisma MongoDB Atlas. So you can start from here. So I will share this link with you. So you can go ahead and start with uh, the implementation. So use JavaScript here. So first, before we go into the like implementing like ORMs, we start looking into the ORMs. We have to create a database in the first place. So I'm going to create a MongoDB Atlas database for this one. If you want, you can actually like use MySQL or Postgres, so related database. So this one, so as you can see, I have a couple of like Postgres database. I'm going to use a MongoDB for this session. So you can go to the MongoDB Atlas, cloud.mongodb.com. I will share this one as well. So in here, so in the MongoDB Atlas is in if you are creating a account using your Gmail or any other authentication mechanism. So this is your dashboard. This is where you can create databases and collections. So the difference is in document database and relational database. So in relational database, we have relations like tables. In the table, we have rows and columns. But in document database, we have collections and documents. It's similar to having a folder and any files underneath that folder. So it's similar to that approach. So for example, if we use this, let's say this is a collection, which is a folder, and under this collection, we may have files that is called document. That's why it's mainly called document DB. So what I'm going to do is I'm going to create a database, basically the a collection. So you can use this plus icon over here and create a new deployment. So because when you are like creating a database using MongoDB Atlas, it is actually automatically create a database instance, MongoDB database instance for you, and it will automatically deploy it for you as well. So you have a hosted database on the MongoDB platform, right? So I'm going to create plus here, basically a new database cluster. So which means you can have multiple collection, because we have a cluster uh, in MongoDB. Under that one particular cluster, you can have multiple collection of databases. So if you, there are three main like approaches you can create, which is serverless uh, and dedicated server. If you want a dedicated like CPU memory into a database, you can create a dedicated a database instance, but it costs you money. So for this, I'm going to use shared database. So if you're when you're creating shared database, you have multiple cloud providers. In MongoDB Atlas, they support AWS, GCP, and Azure. So which are the most popular and well used cloud providers in the industry. So if you choose any cloud provider, so let's say AWS, you have multiple regions. So in here, you can create your database in Mumbai. So this one, it is a free tier. So you can create a database cluster without cost any money. So I'm choosing Mumbai. So this is basically AP South one means the AWS region. So and if once it is created, yeah. So I cannot create a new one because my free tier is already gone. So I'm going to like let me free tier or have cluster, select another tier. So I cannot select another tier. Yeah. So when let me go here. Yeah, this one. So I'm going to give. I'm going to use Hyderabad AP South 2. Then I'm going to give my name a cluster. Let's say ITP cluster, right? You can give whatever the name that you want. So once you create a cluster, you can go ahead and click create cluster. Oh shoot. So it's tell me to add my like billing like because it is not a free tier. So I'm going to go back. So because since I have already created one, I'm going to use that instead. So, but when you are creating your first database, you can use a free tier without cost you any money. So I'm going to cancel this. So because I have already created the like uh, basically database deployment there. So then what I'm going to do is that like I'm going to like database deployments. Yeah, I'm going to click connect. And if you click connect and you go to the drivers, basically we are using Node.js, you can grab your connection URL for your database. I'm going to copy this and I'm going to keep this database URL here, right? Okay, cool. So then what I'm going to do is, yeah, in here, we go to the project. So let's go to your environment variable file, right? So I hope you clone this project. As the database URL, you can paste this environment variable, basically the one that we have copied from the MongoDB Atlas, right? And then you have to give your password to your database actually. When you are creating your first MongoDB database, you have to create a password. So if you want to update your password in here, you can go to the database access here, and then you can edit your user. My one is this one, my MR money tracker, so which I have created a few days back as a pet project. So in here you can use password, and you can edit your password that you want. So I'm going to edit my password. So I'm going to use this one, which is suggested by the Chrome. So I will copy this one, and don't share this password with anyone, because if you're in a production level environment, so if you share any credentials from your backend, you are screwed actually. So don't share any of these password with you, any of the public, like basically publicly, don't share these password and credentials, especially when you are working with backend environment, right? So, and then I'm going to click update user. Yeah, so it is updated. So which means if we can connect to this particular database, right? So which is this one. This is our cluster actually, right? So I'm going to click on browse collection. Basically, where our database exists. So here, so I have a couple of pre-loaded data sets. So I can explain how collection and document works in MongoDB. So in MongoDB, this collection is basically equal to a database in relational database, right? This collection is equal to database. So basically, this one, this is the collection. So let's say sample Airbnb is a collection, and under collection you can have documents basically in here. This one, right? In the document you have like records, basically the document. This is in MongoDB. This is called document, right? So this is equal to a database record in relational database, a row actually. You can have any fields like depending on your implementation. For example, let's take a user. You can have ID, first name, last name, email, and the password, etc. Right? So this is basically a database flow when it comes to relational database, right? This is equal to something like this. So let me have a predefined database. So let me query. So this is equal to something like this. This is a row in relational database. So it is equal to this document right here. Right? So that's the main difference between document database and relational databases. So then we have created our database collection. So you can create a database similar to, by clicking on create database. So I will give my database a name, let's say ITP DB. So collection name, let's say users. So I'm going to create this one, ITPDB, and collection called users. So it will create a collection, basically a database within our collection, which is called ITPDB, and a collection called users, right? Okay, now we have our database set up. So it's very easy in MongoDB Atlas. So let's go to the ORMs, because creating a database is very simple in MongoDB Atlas. So you can create by clicking on few buttons. So then I'm going to go to the documentation right here. So let me zoom it a little bit. So in MongoDB, so you need to have MongoDB running, database running on any, it can be in your local environment, or it can be a hosted environment. So then we are going to create a project setup, which we have already created. And then we are going to grab our first dependency. Basically, we are going to install Prisma as a development dependency, which means we need to use this tag option here. Right? So I'm going to copy this Prisma file, the command, and then I'm going to open my terminal right here. So I'm going to paste. So paste the Prisma. So basically, it will install it as a development dependency, right? So yeah, once you have installed, if you go to the package JSON, if you look at the dev dependencies, under that you have the Prisma installed. So now it is done. So the next thing, is we need to validate whether the Prisma is properly installed or not. For that, you can use npx Prisma to check whether all the commands are properly working. As you can see, if we run npx Prisma, we can have Prisma is running here and all the available commands for you, right? And then the next command that you need to run is we need to initialize Prisma in our Node.js environment, right? So we can use npx Prisma init to initialize our Prisma OR, right? Press enter. So yeah, you can see this folder already exists. So I'm going to basically delete this folder for now. I'm going to remove it from here. Okay, now it is removed. So I'm going to run this command again, npm run init. So once you run this command, so you have a new folder called Prisma. So under that, you have a schema.prisma. So basically, this is the place where you define your database structure, which means basically the models, tables, and the columns that are related to that table, right? Okay. So this is where all of our database schemas implemented. So if you are using like any other ORM such as Mongoose, it is in Mongoose we are basically creating a schema using JavaScript or TypeScript. But in Prisma they have their own syntaxes, which very straightforward. So I will create a database schema with you. So when we are creating, you will like understand it is very like similar to creating Mongoose schema, right? So now we have created a configure our Prisma client, Prisma in our Node.js application. So now we are going to connect our Prisma environment with our database, right? So I'm going to click on connect to your database. So the first thing is data source. We need to mention what are the data source, what is the data source that we are going to use. So in our case, we are not using Postgres. We are using MongoDB, right? And then we need to define give our environment database URL where we can connect to our database, right? So you can basically grab this database URL right here, right? This is our connection URL to our database. And then in environment variables, you can have a database URL or MongoDB URL. You can give uh, whatever the name that you want as the environment variable, and then give this environment variable here, right? So make sure to give the password. And now we have our database connection. So in Prisma, we have a special function called env. Basically, you can pass the environment variable name to this function. It will automatically grab it from the your environment variable file, right? So now we have our basically it is now it is connected to MongoDB Atlas with our database URL. It's that simple, right? So once we have created that, so we can go to the next step, which means defining our database schema. So let me go to the Prisma schema. So in here, everything that you want to create, let's say database tables or any, when it comes to MongoDB, it is database collection in here. You can simply let me here. You can simply start writing model. So model which is equal to a database table. So I'm going to create model. Let's say let's create a model called user. So because we are dealing with users in creating a user and update users. So in here we have created a model. This is equal to a database schema, database table in our MongoDB environment, right? And then for every user, we need to have an ID. So in ID, in MongoDB, if we are working with IDs, we have a prefix called underscore ID. So which is, I'm going to give it as a string. Our database ID is a string. And you can have a annotations, something like this, which is called ID, which means specifying this is a ID on the model, which is a unique value, right? Then the next one is the default. We can have a default value because we are not going to create database IDs from our end. We need to create database IDs automatically from the MongoDB itself, right? So then we use auto. So it will automatically create a database ID for our reports, right? When the time it got inserted, right? And then we need to map this particular ID, right? The ID that we are creating to the Mongo underscore ID, which means which is the one that actually using MongoDB underscore ID, uh, right? So let me load the documents. So which is this one, right? It is going to generate a new ID when we are creating a new record, and it will map that ID to the underscore ID in MongoDB, right? So that is basically it. And then we basically add db dot object ID because this is the object ID in MongoDB databases. But if you are dealing with Postgres, if you go to Prisma Postgres, right? Uh, right here, in here, if you can see, let me go to the schema, Postgres schema. Oh, this is related to like MySQL as well. So it is something like this in MongoDB, in Postgres or MySQL. You can create integer, basically 1, 2, 3, 4, which is similar to this. If you just like this, something like this, right? But in MongoDB, we need to map this ID into the underscore ID field, right? So that's why we are using this map annotation, right? Now we can define rest of the like like fields. Let's say the user need to have first name, so which can be a which should be a string, right? So if you use question mark, which means that field is optional, right? So if you want to first name optional, you can keep the question mark, right? And in my case, I need to have the first name required, right? Then the second one is last name. I'm going to put it as optional, right? And then I have let's say email is a string, and it should be unique, right? So you can use at unique annotation. And then I need to have phone number, which is string optional, and if it is this, it should be unique as well, right? So this is a very simple schema that I have created, right? So you can like let's say I'm going to have another model. So let's say product, right? And in here, I'm going to create the same ID, which is automatically like generated. And then let's say the product have ID, and so yeah, I'm going to use post, very simple one. So user can have, according to this example, user can have multiple posts actually. So we can define a post schema, something like this. And then let's say post have a name, should be a string, and description, right? Which is a string as well. So we can basically make relationship between each other modules. Like for example, in relational databases, we have relationships between databases. When you are like creating ER diagrams, so one user can have many products, and one user can have many posts, and one post belongs to uh, one user, right? Something like that. So you can basically create something like this. So I'm going to create a user because this post belongs to a user, right? So then I'm going to give the type, basically our user model, right? And then I'm going to declare a relationship between user and the post model, right? I'm going to get fields. So I'm going to use this one. So basically, mm, the author ID, which is a string. Let me go to the user ID here, which is a string, and it is a basically database dot object ID, right? And then I'm going to give the field as user ID. So I'm once it is running, I will you can see how all the relations are connected, right? So I'm going to reference to the ID field of the this particular uh, field. So this user reference to the ID field of the user, right? Then not only that, we need to tell our user model, user can have a one post actually, right? So I'm going to have post, let's say post. So basically the post, right? Yeah, post, right? So basically one user can have many posts, right? Post. So this is a very simple schema that you can create. So once you like understand how you can like create schemas, it is very, very simple. You can basically declare all the schemas in one place, and like uh, in Prisma, it will automatically create a database and link all the relation and give you a very good interface for your querying the database, right? So we now we have created our schema, right? Okay. Okay. The next step is, so now we create our schema. So I'm going to go here. So install the Prisma client, which basically used to query the data fields, query the data from our database. So I'm going to install this one as well, Prisma client, right? Like set up these things are a little bit take a little bit time, but once you have set up, it is very much easy to like query the data from your database, right? So querying the database, we can use Prisma client. So we will focusing on querying the database in few minutes, right? Okay, now we have created our database, right? And all the schemas that we need, right? Now we are going to go to the users directory. So in the users directory, we have user.service, which I have explained, where we keep all of our like business logics, right? So now we are going to create a user, right? So let's say in here we need to create our Prisma client in here. So I'm going to, let's say Prisma here. This should be Prisma client, right? So I'm going to use a constructor to initialize our Prisma client. This dot Prisma equal new Prisma client. So I think this should be, sorry, this is just JavaScript, right? We writing on think it is not properly installed. Let me install it. Okay, so yeah, it is there, right? Let me give it a reload window. Okay, now it's working. So now we have the Prisma client. Then you can basically uh, use Prisma client. So for example, let's say if you want to create a like user, you can use Prisma client. Let me go query the database. Uh, yeah, Prisma dot create. So basically, this is JavaScript. So you don't have any auto suggestion from here. So if you are in TypeScript, it will automatically pops up what are the available functions. So we have a data user data here. Let's say this is in here. We are assuming a user can have, let's say, the first name, which is basically user data dot first name and the last name, user data dot last name, and we have email, user data dot email, and also the phone number, which is user data dot phone number, right? These are the only fields that we are going to create, right? And then yeah, okay. So we have a Prisma client. Let's say first user. Let's console this out for now. User, right? So I'm going to create a database user, and I'm going to just console the user out and return the user from our service class, right? So this is pretty much it for the creating a user in the Prisma. Using the Prisma, it is very simple. You basically create a Prisma client, and then you basically create a user in the database. Right? Now, what we are going to do is, I'm going to go to the router, basically the control layer. So in here, I have a user controller, and under that, I have a create user function. So what I'm going to do is basically, I have initialized, basically create an object of user service in our using our user service class. What I'm going to do is I'm going to create let's say const user equal the I'm going to use await this dot user service, right? Create user, right? And for this, we are going to pass request dot body, basically our database data set, right? So instead of here, I'm going to use data as user, right? Okay. Now we have connect our controller function with our service layer that actually create a database user. Now we are I'm going to put a console log in here just to verify all the data is coming correctly. And then we basically connect our user router with the endpoint API endpoint, right? Okay. And then what we are going to do is we are going to basically create a router from the express router, and then we are going to create our API endpoint, and then we export this user router to our root of our project, which is app.js. So in here, I have user middleware, basically use API slash router. And if any front-end user, any other client actually call this endpoint, it will automatically map into the user router, right? So I'm going to run this application. Let's see npm run dev. Yeah, we have a error. Let's see. Sure, I need to use another command called Prisma generate. I forgot to do that. Prisma generate. Yeah, so it will automatically generated a Prisma client. If I just, yeah, now it is working. So as you can see, so let me, once it is generated for the Prisma client, you can use basically something like this: const user equal. We are going to use asynchronous call. This dot Prisma client dot. Then we can use define the user. I forgot to add that. Create user, and we can use create here. And then if you just put square brackets, if you just auto suggestions, you can have a data field here, right? If it is object, if you use again here, you can see the properties that we are going to store in the database, right? So which is our first name. It's called user data dot first name. I forgot to do that actually because we need to have a Prisma generate that actually automatically generate basically map our schema that we have defined in Prisma schema.prisma into a JavaScript objects, right? So that's why this will automatically generated. So first name, if I just put last name, it is automatically give the like which is called auto suggestions. Last name, let's say email, is for data dot email and then phone number, user data dot phone number, right? These are all the things that I want. So this will give us a user object, right? And then we simply return that user object into our controller, and the controller will basically return that into our front end application, right? So let's give it a try. PM run dev. Okay, now our service is started properly. So let's see whether our endpoint can access using a Postman. I'm going to use Postman right here. So I'm going to create a new request. So it is a post request. So when you are using a Postman, actually, since most of the host names, like for example, your data endpoint host name is reused in multiple requests. So instead of repeating the same like host name for again and again for each request, you can use environments in Postman. So basically, you can create a new environment. Let's say ITP node env, and here you can give a variable name, let's say host name, right? And it is we will initialize it to HTTP localhost colon 4000, because our service running on if I go to the let me go to the app.js, it is running on port 4000. So I'm going to save it in here, right? So now you can just basically put double curly brackets and then use sorry, you need to select the environment. So currently no environment is selected, so I'm going to use ITT node DNV, and if you put two curly brackets, you can see the host name automatically pops up, right? And then you can define the route. So basically API/user in here, API/user/create, which is our endpoint name. If you go to the user.router, which is our /create endpoint. Now we are going to create our generate the body. So I'm going to use row, which is JSON, right? JSON. And then here, what I'm going to do is I'm going to give first name, let's say Nimal, last name, Nimal user, right? So the email, I'm going to give it as nimal@gmail.com, something like that. The phone number I'm not going to give, because as you hope you remember, phone number is an optional one here, right? We can ignore that, and also the last name as well. So let's see if we hit this endpoint, what is going to happen, right? So I'm going to like basically create and hit, and yeah, what happened? Local host, oh sorry, my bad, it is not 400, it's 4000. So I'm going to hit enter. So as you can see, method called, what happens there? So I'm going to, I have called this endpoint, and it should call our controller, right? And then within the controller, we need to, we need to call create user. Actually, I forgot to, like, I use get user, which is wrong function. So I'm going to call it again. So now, as you can see, I have the data object that has been printed, but in the Prisma says something went wrong. Invalid invocation, wait, Prisma, database string is invalid, connection error. Okay. So now, as you can see, when you are using ORMs, you can understand clearly understand what went wrong. So it says our database connection is invalid. Let me check this again. MongoDB. This is our database record. Should connect. We'll see. Let me go to the MongoDB Atlas here. Go to the overview and let's connect. Shell, yeah, I'm going to use JS. Right, this is our database query. Why is it not working? This is our query, and this is our password. Use this one. I'm going to like copy this one here. Let me restart our project. Okay, now let's see the same error occurs. Try this. Let me check. Must be an option must be a Boolean database URL. Please refer to the Prisma connection URL. So I'm going to go to the error. Actually, it throws me. So I'm going to define. It should give me a proper. Let's say connect MongoDB Atlas with Prisma. Database Atlas. We can create dedicated. Okay, we have all done that. Now let's go here. Cluster name. It should give us a URL. I don't know why it is throwing me error. So let me grab this one, which is this one. Let's test this with our existing credentials. So this is the database URL that they have given. So I'm going to use this one, which is this is our user, and then this is our password, right? This one, and this is our cluster name, which is mongodb.net, and then we need to give the database name, which is if I go to the MongoDB, our database name is ITPDB. So I'm going to use ITPDB. So I hope this will fix the issue. So let's see. So let's try it again. Yeah, now it has been created our user. If we go to our database right here and give it a refresh, and it should create a user object like this. As you can see, we have our first name, last name, email. So now the creation part is done. So it is very simple that you can, when you configure the Prisma or any other ORM into your Node.js project, is pretty much easy to access, like basically create all the database layer things like create, update, delete, or even like you can use migration. So if you like, for example, if you just search Prisma migration, database migration, you can simply use this tool. So this is actually a very good tool if we are working with new in the industry. Also, if you are using Node.js, most of the time industry actually use ORMs. So they are not going to like in Node.js, we are not going to like give queries similar to SQL. They are mostly using ORM when we are working with Node.js. You can use database database migrations. Not only that, let's say if you are creating a financial application that heavily use money transaction, you can use database transactions as well. So it is really like uh, like really amazing tool that you can use into your application. So instead of like hard like give define schemas using mongoose, right? And not only that, actually, so let's say at a given point you want to migrate from, instead of using MongoDB, you want to use Postgres, which is SQL database. All you have to do is basically give the provider name. Let's say if you want to use Postgres, you can use here Postgres as the provider and the database URL. Only thing you have to do is just get rid of this part, because this part actually only related to MongoDB. So now you can use Postgres as your database. It's that much simple. So that's why I'm recommending you to like use a ORM into your projects. That actually helps uh, like your database query process much more better. So that is create. So it is similar to like create. You can basically use get user. So all you have to do is we have the user ID, right? So I'm going to create const user. Well, await. So now you can see that once we have created that ORM, it is more easy to like query anything in the database. Use this dot prisma dot user dot, we can use find what basically find unique, find many, find row, find first. So let's see what are the available update group by find unique. Yeah, let's say find first is the first occurrence of the user, and you can use use where clause, and where you can your ID is equal to the user ID that which is passed, right? Now this is the user that we want to return. All we have to do is just return this user to the front end. So now, as you can see, this is really like simplify our service layer. All you have to do is like, since we are creating like for file for each and every scenario. For example, to handle the business layer, you can have a service file. To have a like controller, you can have a controller file. So which actually helps you to like organize your application in real world applications. So now we are going to do is we have the get user function. All we have to do is just const user await this, sorry, this dot user service get user. All we have to do is request dot body dot user ID, right? Now once we have get the user, we just, instead of message user, just simply return it, right? Now we have the uh, control function created. Now we go to the route. So all we have to do is tell our user router to create a get endpoint, HTTP endpoint for user. I'm going to slash. I'm going to use user controller, get user, like bind this with user controller. So the reason that I'm using bind, so as you can see here, in the controller function, we have to pass request, response, and next function. So the reason that we are binding this with the user controller, when we are bind, it will automatically give all the request or parameter request data to the control function. We don't have to use something like this. So let's say if you are using get user, you have to pass request, response any. Since you are binding this value, which is coming from, if you can you use this approach as well, is basically request, response, next, and you can pass this one to request, response, and sorry, next. So which is like give, like you have to do this for each and every like endpoint. So instead of that, you can use bind that actually automatically give all the necessary parameters to the controller function, which much more clear when you are coding this approach, right? All you have to do is bind the user control. Now we have the get endpoint. All we have to do is go here. I'm going to create another function, basically the endpoint. So I'm going to use ITP environment hostname / API / user. That is my endpoint. All I have to do is in the request body, I have to pass the user ID, basically this one, user ID. So I'm going to grab the user ID from here, which is automatically generated. So I'm going to paste it in here. So once I passed, it should give me the user data like this, right? So you can do more like like querying, like update and delete, similar to this. So I'm going to like before I'm so I know it is almost past time, so I'm going to give you an this is basically part operation. So I'm going to give you an explanation and how you can implement these, like uh, basically we have used create and read from CRUD. We have to do update and delete. But before that, I'm going to, since the time's went past, so I'm going to use create a login. So for your backend application. So because as I mentioned in the early stage, when you're dealing with developing a backend, actually logging is very much important. So I'm going to use utils directory to create a logger. So the package that I'm going to use is which is called Winston npm Winston. It is a highly recommended like package, npm package. It is like uh, well maintained, and as you can see, it is last updated 20 days ago, which means still it is updating. So when it comes to industry guys, so it is especially working with Node.js or any JavaScript related framework, choosing like dependencies or packages is really really important. So let's say if you are using a package that is not maintained after, like let's say from 2017 onwards, most probably it may have vulnerabilities, it may have security issues. So when you are choosing a package, just go here and see whether how many weekly downloads and last published date. And also remember to go to their official GitHub repository and just see what are the issues that has been raised to this particular package. So especially when you have security related issues, let's say you want to handle security, most of the time these security issues, the vulnerabilities coming from the packages that you are installing to your application. So in that case, it is very much important to look at all the like issues that has been raised, and also whether this package is still maintaining or not, right? So that's why I'm using Winston, which is highly recommended. So in Winston, so I'm going to go to the official GitHub page. So in Winston, you can basically create a logger. So I'm going to create a logger. So I'm going to get rid of all of these. So we are going to create it from scratch. So yeah, paste it in here. So now I'm going to open the documentation. So as I mentioned, this is how I code actually. Like most of the time, I'm looking at the documentation and implement it there. So that's how I do. So basically we need to import Winston. So you have to install Winston. So let's copy this one, remove this one, we npm install Winston, right? And then we are going to import Winston, uh, Winston, right? Now, start with that. Now we need to create a logger. So simple logger. So I'm going to create logger from Winston create logger. There's another function called create logger. So in this, for this create logger, you can pass any configurations like the level that you want to handle. Like say in the levels, it says you can use info or any error debug. So there are a lot of levels that you can use in lot of means like there are multiple levels that you can use in logger, use for your logger actually. Then we can create the format. So I'm going to create a custom format actually. So I'm going to, instead of their own format, so I'm going to create like I'm going to use destructuring from the Winston dot format, right? From here, we can import the combine, which basically we are combining the Winston logs with our customized logger and the timestamp and also the message, sorry, metadata. Sorry, here it should say, sorry, printf. Basically, the printing the logs to the file or console. So then I'm going to create const custom. Basically, you can grab this implementation to your Node.js project in your ITP because in the ITP, they are basically, instead of actually CRUD operations, they are mainly looking what you have done with the project, basically the logging, database, actions, all that kind of thing. Because CRUD is a one part. This one, you can add more value to your project actually, handling logs properly. You can showcase this in your Viva sessions as well. So I'm going to create a custom format and then use printf, which basically print anything to the console in our custom format, right? And then we have a callback function like this. In this callback function, we can access the message, the actual message, timestamp, and also let me check, yeah, level, yeah, the level. With the level can be error, info, debug, etc. Right? And then you can customize your logger, basically return the logger that you want to uh, have in your application. So I'm going to give the timestamp first, and then I'm going to give the level of the error, and then I'm going to give the message. So this is my custom format, right? So I'm going to use info. So in you can do something like this. Instead of telling all the way running, display all the logs into info. For example, let's say if you are in production environment, process.env.node.env. So if you are in, let's say, development environment, let's say development, display all the logs as debug mode, right? Debug, sorry. And if in any other case, especially in production, it's just info, right? Now we can have the format, which is our custom format. Now we are going to use this combine function that actually combine the Winston default formatter with our custom made formatter. I'm going to use combine, and then in here I'm going to use timestamp, basically the other function that we can get the server time, and then we map it with the custom format, right? And then this is done. Now our custom format is successfully connected. Now in most of the production scenarios, instead of just putting all the logs into a console, right? Because if the console like cleared, we don't have any access to the logs. We need to write our logs into files so that in any incident, let's say some API got crashed, you have a file that actually you can go through and see whether what went wrong, right? So then in the instance, we have a property called transport. Basically, transport all of our logs into a separate file, right? You can define array of files actually. So to do that, I'm going to save all the error logs into error.log file, right? If anything related to errors, I have a separate file to just to save error logs, right? For any other case, I'm going to I'm going to save every other logs into a combine.log, including errors. I'm going to save it there. So all you have to do is basically create a new Winston transport file, basically transport file, and in here you can transports.file. In here you can give the file name basically. So I want to store all the error logs, error.log. The level that I want to pass is error, right? This is the file that I want to pass. I want to store all the error logs in this particular file. To any other case, I'm going to use new winston.transports.file, and I'm going to give the file name as, you can give whatever the file name that you want, combine log, right? And then any other case, it will handle automatically. Now all we have to do is basically export this one from this particular logger, right? I need to remove it from here, not necessary. So now we have the logger. If we just start our application, npm run dev, right? So I have started my application. Let's say I want to create a new user. Need to create a new user, right? So the user has been created. Now, if I go to the combine log, as you can see here, so it is called info service started. So let's say I want to display a log whenever user has been created. So all I have to do is go to my API directory under the source user service. I need to import this logger, import logger. All I have to do is just basically, let's say logger dot info. Then I can pass the message user created, something like that. So most of the time, this has been properly handled like this using try catch block. We have tried this one. If anything error occurs, I'm going to return null. Meanwhile, I'm going to log this error message. Logger dot error. You can use error dot message and also error dot stack. Basically, the where this error occurs, right? So in here, let's say I'm going to like remove this one. Just try to do this. I don't know why that it should throw an error. So let's say I want to throw this error, like throw new error here. Just after user created, something went wrong, right? I want to throw this error whenever user is created. So I'm going to say it. As you can see, user data has been sent as null. So if I go to my combine logs, I'm seeing something went wrong here. And also if I go to the error log, I'm only seeing the error. So you can actually give more information to this error in this using this approach. So that depending in your application, you can use the whatever the line that actually the error occurred, something like that. You have more room to like add more logs into your log files, right? So not only that, apart from writing all the logs into a combined file, I want to like uh, log all the values like logs into a console when it comes to a development environment, right? Because otherwise we have always we have to go to the log files, which is not ideal in a development environment. So in that case, I just check if our end process of dnv dot not dnv it is not equal to production, right? Which is development environment. If it is that, if that's the case, all I have to do is I'm going to use logger dot add and then create a new instance dot transport transport dot console. Basically, print all the logs into the console. In this constructor, I'm going to pass the format format that I want to pass instance dot format dot simple. Simply pass the format, right? So which is this one. So as you can see, now it is passing the format. Let's give it a try with our custom format. Here you can see now it is using our custom format instead of the default format, right? So you can do logging similar to this approach. There are so many ways of doing logs in backend, but this is commonly used approach that you can use. Yeah, so that's so basically due to the time limits, I'm going to stop there. So just let me know if you want more info, like info regarding the request validation. So it is better if I have time to like have explain this validation as well. But we'll see in the future. Like if you want request validation as well, just let know the let MS Club knows. So in the future, we will try to have a proper lengthy one to handle request validation and more sophisticated logging in your backend applications. So I will share this code with you so you can go ahead and see the implementation, and you can use this folder structure. So I have put here, you can grab this code. So I'm going to create a new branch with the implementation. If you want to just only to grab the folder structure, you can use this main branch. So I'm going to have a separate branch called implementation. So you can see the implementation right in the GitHub. So yeah, so just let me know if you have any questions. So yeah, you can just basically go here if you have any issues. Just create any issues. I'll ask it on the GitHub as well. So yeah, that's pretty much it. So I know it is lots in short amount of time. So yeah, thank you.
Thank you, Mr. Rusiru. That was a very informative and valuable session. So before we end, this is the reminder for you all to fill the feedback form, which is sent to the meeting chat. And also, I would like to take this opportunity on behalf of the MS Club of SLIIT to thank Mr. Gihan Sarvardhana and Mr. Rusiru Bandara for sacrificing their valuable time for us. In conclusion, the videos of the day one of ITP Guide 7.0 have already been uploaded to the YouTube, and this will also be available there very soon. Yeah, so stay updated with the YouTube channel of MS Club of SLIIT. Yeah, that's pretty much of it. Thank you and good night.